Hello, everyone. Thank you for joining. My name is Roy. I'm a solution engineer at JFrog. In the past, I was a software engineer as well. And of course, in addition to DevOps and coding, I also love cooking and baking. But I think we will focus on DevOps today. So let's go over the agenda. I think we can start with the DevOps vision, followed by the JFrog platform overview. And from there, we will deep dive into Artifactory, talk also about automation and build integration. And then I will give you a demonstration of the platform. And of course, you will have time for questions at the end of the session. Okay, great. So let's talk about the DevOps vision. The DevOps vision focuses on managing seamlessly all of the operations that you see, all of the phases that you see in front of you automatically. From planning to coding, building, testing, releasing, deploying, operating, and monitoring. Now, of course, with the feedback from monitoring, we can start planning again and start another iteration of this never-ending cycle. Now, let's identify the areas in which we can do something and talk about binaries. So what are the fundamentals when we are writing code? We start by writing our code, our source code, in which we use open source dependencies. Those could be NPM packages or Docker images and so on. We build our code and reproduce binaries. And from these binaries, we are producing packages. Those could be several binaries, a single binary, and so on. Now, these packages have to be managed and stored somewhere. And let's discuss about what we can do when it comes to binaries. So we can use a shared file space, right? That is an option that we have. But then two questions come into mind. First, who is going to handle all of the specific protocols for the different technologies that we are using? The second question that comes to mind, we will need an API to manage this shared file space. Who is going to expose this API and write it? Another option that we have is to use version control system. But then again, it depends on which system we are using, right? Some of them can store the content in a text format. Some of them can store a blob. It can be versioned by content, and it can also be versioned by name. It depends. It can be mutable or immutable. And last but not least, we can use a binaries management tool, like JFrog Artifactory. Now, before I dive into Artifactory, I want to give you an overview of the JFrog platform as a whole. So JFrog has an end-to-end DevOps platform, which takes us from the source code level all the way until to the delivery or the distribution level of your software. Now, it is comprised of several components. One of them is Artifactory, which we are going to cover today, but there are more components. And again, they all comprise one unified platform. So if we take a look on the left part, we can see Artifactory, which is where we are going to store and manage all of our binaries, both ones that we are consuming from public resources, but also ones that we are building as part of our CI process. Next, we have X-Ray, which is our solution for software composition analysis. Now, software composition analysis, very, very briefly, basically provides you with insight into third-party dependencies and open source software from two aspects. First, the security aspect, and second is the licensing compliance aspect, making sure that we are not including any licenses that we are not allowed to use in our software. Next, we have mission control, which provides us with trends and insights into our platform deployment. For example, what was the most downloaded artifact in the past 30 days, or performance of the platform itself. We also have pipelines, which is our CI/CD solution that can work alongside other CI solutions, in addition to them, instead of them, and so on. And distribution, which is our mechanism for distributing software to locations that we call edge nodes, that you can think of them as read-only Artifactory endpoints. Of course, if any of this is of interest to you, you can always reach out to us to discuss in further detail and schedule a technical session. But now we will focus on Artifactory. So what is Artifactory? Artifactory is a universal binary repository manager. This is where we're going to put all of our binaries, both the binaries that we are consuming. So if, for example, if I'm a Java developer, I will put all of the Maven dependencies and consume all of the Maven dependencies through Artifactory, but also binaries that we are building. So for example, if as part of my CI process, I am building a Docker image, then this is where the Docker image will be hosted on Artifactory as a Docker registry. As I mentioned earlier, it is going to proxy remote repositories for us. So if we take a look at the diagram below, we can see two setups. One is with Artifactory, and the other is without Artifactory. Without Artifactory, we can see that all of the clients are accessing remote repositories without any intervention. This could be the CI process, this could be a developer on the local machine, and they're fetching dependencies from remote repositories freely. But what happens if one of those repositories is not available? Or what happens if we want to enforce some policies on what type of dependencies and what the dependencies that we bring into our environment should look like? In the left diagram, this is not happening. But in the right side of the diagram, you can see that with Artifactory, all of the clients, and again, when I say clients, these could be developers, that this could be the CI process and so on, are fetching dependencies through Artifactory. Now, this provides us with several advantages. One of them is the fact that Artifactory is caching locally the dependencies that are consumed from those remote repositories. So for example, if we have an NPM application, a JavaScript application that we are building with NPM, and we are fetching public dependencies from remote repositories, then those dependencies are cached locally, so that when our CI process, for example, starts running, it will already have the dependencies locally cached on Artifactory, faster to retrieve. And of course, if one of those repositories is not available, the dependencies are still available on Artifactory. Another advantage is the fact that we can enforce policies with Artifactory and with X-Ray as well, our software composition analysis solution, on which dependencies or which binaries we bring into our environment. Now, Artifactory has a lot of features, but I want to focus on a few of them. So first, Artifactory is highly universal. We support more than 27 package managers at the moment, and this is a number that keeps on growing every year. Of course, we support all of the popular technologies. Artifactory provides us with the ability to add metadata on all of our binaries, on all of the different types of the packages that we support. And this is going to help us manage our binaries and better understand at which maturity level they are, what is the context that created those binaries, and so on. Artifactory uses checksum-based storage. Now, this actually means that Artifactory will calculate the hash for a specific binary and store it only once. Now, an artifact or a binary or a package could be represented from multiple contexts. For example, from multiple repositories, as we will see in the next few minutes. But still, the content itself, the file itself, will be saved only once. This makes Artifactory highly efficient in storage consumption. Other than the capabilities that Artifactory already has out of the box, Artifactory was built for automation, which means that you have several tools, which we will discuss some of them later on today, to build automation with Artifactory, whether it's user plugins that allow you to run code on your Artifactory deployment, the command line interface, the REST API, our own query language, which is called AQL, Artifactory Query Language, and so on. But of course, there are a lot of integrations that already exist for different tools, for CI servers, for IDEs, and so on. Okay, now I'm going to cover checksum-based storage in further detail. But the idea is that checksum-based storage provides us with deduplication. So again, if we have more than one representation of the same content, it is going to be, it's going to exist only once in our storage, which is going to allow us a free copy and move action because the file itself is saved only once. This applies also for deletion. And again, it is highly efficient. It helps us with the performance and so on. Okay, I want to go over a classic software development lifecycle flow and show you where Artifactory comes into play as a single source of truth. So usually what happens, there is a developer and they are declaring new dependencies. If they're writing a JavaScript application, for example, they're declaring dependencies in the package.json. If it's a Java application that uses Maven, it's the POM XML, and so on. And those dependencies have to be resolved somehow. We're going to use Artifactory for that. Now, Artifactory, as a proxy for other dependencies and for other repositories, is going to fetch those dependencies from remote repositories. For example, the central NPM registry. Following a few changes, the developer usually commits their changes, and a VCS change occurs, which triggers our CI server. Now, our CI server is going to build using the different build tools or package managers. And again, the CI server is another client of Artifactory, and it's going to resolve dependencies through Artifactory. Now, there's one important note to say here, because the dependencies that the CI server is now resolving from Artifactory should already exist in Artifactory's cache, because they were declared by a developer that already fetched them through Artifactory. So they will probably exist in the cache if they were not cleaned for some reason, which is going to make our CI process faster. Later on, we want to push our built artifacts into Artifactory, but we also want to push the build information or the bill of materials with all the different dependencies that we used in the build, different environment variables, and basically the context that created this binary. We'll see more on this as we go along. And now we can start contributing even more metadata if we want to integrate with another tool, for example, static code analysis, and we want to tag our binary if it was scanned or not, and maybe if it was scanned, what were the results? And the last stage would be to deploy to production. Okay, Artifactory presents three different repository types. Very generally speaking, of course. There are more repository types, but very generally speaking, we will cover three repository types. First is a local repository. The second is a remote repository. And the third is a virtual repository. Now let's cover every one of them in detail. A local repository is a physical, locally managed repository on Artifactory's file store. And this is the repository that we want to push artifacts into. So if we're building a Docker image, this Docker image will be pushed into Artifactory, into a local repository. Of course, we will also consume artifacts from this repository as part of a virtual repository. We will see what that is in just a minute. Okay, next is the remote repository. The remote repository proxies other types of repositories. Those could be repositories that exist on another Artifactory deployment, or public repositories like the central NPM repository. Now, it also caches, which means that if, for example, we're consuming NPM dependencies through the remote repository, then those will be cached on the repository's cache. And on top of a local and a remote repository, we have a virtual repository. A virtual repository basically aggregates different types and a different number of repositories within it. Now, what this provides us is with one single URL for our package manager or our build tool to work with. So, for example, we could have multiple local repositories within the virtual repository, and let's say one remote repository, and only use one URL so that when we deploy an artifact, it will automatically go to the local repository, to the default deployment repository, which will be of type local. And when we try to pull an artifact, according to the resolution order, we could iterate between the different repositories, again, depending on the resolution order and where the artifact actually exists. We will see that in the demo. But the artifact could be pulled from a remote repository, from a local repository, and so on. Okay. So I've mentioned earlier that we want to integrate our CI server with Artifactory. Now, our CI server is using Artifactory as a client. It consumes dependencies through Artifactory, but it also uses it to store binaries, and it pushes binaries to Artifactory. For example, a Docker image. As part of the build integration, or the engine behind build integration, the CI server is going to push a JSON file that is called build information, build info, with all of the context of this specific build, which is going to allow us, for example, to explore the different dependencies used in this build. It is also going to allow us to understand more about the build environment, about different environment variables and so on. And it's going to create a link between the CI server and Artifactory, and vice versa between Artifactory and the CI server. We support integration with multiple CI servers. Of course, JFrog Pipelines, which is our solution, which is our CI/CD solution, is integrated natively with Artifactory, but also Jenkins, TeamCity, GitHub Actions, and so on. And even if you're not seeing a CI server that exists here, it doesn't mean that we don't support it. And anyhow, with the JFrog CLI, you could basically integrate every CI process with Artifactory. Okay, now we have a lot of binaries, or the number of binaries is ever increasing, and we need to find an efficient way to manage them. So the idea is to use naming conventions to name our repositories and to give them a meaning through naming. So usually what we will do, we will create a repository that will first mark which team or which project is responsible for this repository and is using this repository. Then we will specify the technology, if it's a Docker repository, an NPM repository, a Python repository, and so on. Then we want to mark the maturity of the repository. So for example, we could have a local repository that is used for development, and a local repository that is used for QA, and a local repository that is used for production. Again, we can infer what is the maturity of the repository through its name. And last but not least is the locator. So if this is a local repository, or maybe this repository is another Artifactory, exists on another Artifactory deployment in a different country, for example. Let's say that I have multiple Artifactory deployments, multiple sites of Artifactory on the globe. Maybe I have a site in Paris and another site in Washington, D.C., I will use the locator to mark that. Another important concept that we are going to see as part of in the demo is build promotion. As part of build integration, one of the things that we want to do is to promote our build. Now, this basically means that we either tag our binaries, our artifacts, or we move them between different repositories and mark the maturity level of the package that we promote, of the binary that we promote. So if the CI server is now building a Docker image and it gets pushed into a repository that is marked development, and after some time, after some tests, it can move to a repository that is used for QA, and then for staging, and then for production, so that we can take a look at the binary, its location, its tags, and understand what is the maturity of this binary. Okay, now I've mentioned metadata earlier, and I want to further explain it. So we have different types of data that we can add to Artifactory through a CI/CD infrastructure. Now, it is divided into different categories, but for example, part of the metadata could mark or could explain which dependencies were used for this artifact, what were the environment variables, from which system it was built, what was the build name, the build number. We will see all of that in the demo. We can also add properties to define or to mark the maturity level, production readiness, as you've seen in the previous slide. And of course, we can also have metadata that relates to statistics. How many times this artifact was downloaded, when was it added, who modified it, and so on. And basically, every type of data that you want to add on top of a binary could be added. So if you want, again, to integrate with another tool, if you want to maybe not just mark a binary as ready for production because it was tested by the QA team, and maybe you want to also add how many tests this binary passed or failed, you can do that as well. Okay, there are a few links here that are very important and that I advise you to take a look at regarding automation. So Artifactory has a very rich REST API in addition to the JFrog command line interface that you can also use, which can be used together with Artifactory or with the other JFrog products like X-Ray and distribution. Different CI server plugins, AQL, which stands for Artifactory Query Language, that helps you query Artifactory. For example, search for all the builds in a specific date, and user plugins. Okay, let's continue with a demo. Going to share my screen. Okay. I believe that in a few moments you should be able to see my screen. Okay. So first I want to give you an overview of Artifactory and of the unified platform. So what you're seeing here right now is the packages view. And the packages view enables you to see all of the different packages that exist in Artifactory. I can, for example, filter it by the package type. So for example, if I want to take a look only at NPM packages, I can do that. The build section, which contains all of the builds that exist in Artifactory, and these are all different build processes. The artifact, all of the different repositories that I have in my Artifactory instance. This could be, of course, refined and filtered. So for example, if I want to take a look only at Docker repositories, I can do that as well. And basically, all of this is part of the application tab of Artifactory. This is the tab that users that are not admins can see. If I navigate to the administration tab, on the other hand, I can create repositories and control. Like I said, we have several types. Local, remote, and virtual are ones that we covered. We haven't covered distribution. I can control identity and access, security, if it's different ways of authenticating with Artifactory, and so on. Now, I want to focus on repositories and on creating repositories. So let's create a local repository, and let's use npm as the package type. Now, I'm going back to naming conventions, and if the project that I'm in right now is the webinar, the technology is npm, and the stage or the maturity level of this repository will be development, and it is a local repository, then this will be my repository name. I can choose which layout I want to use. I will go with the npm default. I can add a public description, which will be available to all of the users. So let's say this is a repository for an awesome webinar. And I can also add internal description that is relevant for the administrators. So I've changed the description. Include and exclude patterns, which help us prevent binary spoofing. What patterns, binaries that are consumed from this repository must contain and what they must not contain. And of course, we have more settings here. For example, we can black out this repository, which means that artifacts will not be pulled from it, nor deployed to it. And we can also define replication, which is basically replicating the content of the repository to another Artifactory repository. Let's leave it at this. Just save and finish. And now let's create another repository. Again, another local repository, but this one will be used for production. So again, going back to naming conventions, webinar npm, but I'm going to change it to production now. Nothing else needed here. Let's just save and finish. So now that I've created two repositories, as you can see them, two local repositories, let's create a virtual repository. Oh, I've selected local. My mistake. Okay. Let's create a remote repository. And let's choose npm. You can see that by default, it goes to the central npm registry. Again, we can choose the layout, include and exclude patterns. We can mark this repository as offline, which means that no new artifacts will be pulled from this repository. So if we're trying to resolve a dependency through this repository and it does not exist in the cache, it will not be fetched from the remote resource. We can also define which proxy we want to use with this repository. This is relevant for network administrators. And of course, there are more settings here that we can check. For example, the blacked out option that we just discussed, but let's leave it at that. And let's just call it webinar npm remote. Okay, great. So we have another repository, a remote repository, and now we can aggregate these three repositories within a virtual repository. So I'm creating a virtual repository. I'll select npm, and let's call this webinar npm. Since it's a virtual repository, we don't have maturity, and we don't have location. And let's include all of the webinar repositories within this virtual repository. Now you can see that within the included repositories, we have our resolution order. So first, we will try to resolve dependencies from the development repository, then from the production repository, and then from the remote repository. This could be changed, of course. We can decide that we want to resolve from production first. And we also need to choose which is going to be our default deployment repository. I think that the development one is the one that makes the most sense. Again, more options here, but let's keep it simple for now. So we have actually just created our repository. And if we go back to the tree view, this is what our topology looks like. Virtual NPM repository, 2 local NPM repositories, 1 remote repository, and together with the remote repository, we have a cache. Okay, another thing that I want to show you is build integration. As you can see in front of you, these are all the different build processes that exist in Artifactory currently. And I'm going to also show you a build on Jenkins that corresponds with Artifactory. So just 1 second, please. Let me just share my screen with Jenkins. This is going to take a minute. 1 second, please. Okay. Let me choose my Jenkins window. Great. You should be able to see my screen in just a minute. Okay. Great. So this is my Jenkins instance. I've selected one specific build process. It's called npm sample with violations. The violations relates to X-ray violations that we did not cover today, but let's leave it at that. And let's take a look at the different builds in Artifactory. You can see that I have a build here that is called npm sample with violations that correlates to the build process that we have in Jenkins. So again, what we're seeing here is basically this build process. And as part of build integration, you can see which were the modules that were produced in this build. It's an npm package, which dependencies were part of this build. We can examine this specific build or this specific execution or the previous execution. For example, the previous execution number 3, whether any of the artifacts that were deployed changed, the dependencies that they change, environment variables, and so on. In this case, I don't have any environment variables. And as I mentioned earlier, basically build integration pushes a JSON file, which is called the build info, which marks all of the data that you just saw. Let's see another example of another build. For example, Docker sample. And I want to show you 2 more things as part of this. So if we navigate to the release history, this is where we can see the promotions that happened on this build, on this specific execution. So you can see that 2 promotions here happened. First, it was approved by the security team, and then it was approved by the QA team. Sorry, the other way around. The QA team and then the security team. And this is metadata on top of the binary. And one last thing that I want to show you. 1 second. There it is. Sorry, my bad. Okay, so just summarizing, builds is where you're going to see all of the builds that were published with the context of the build and the artifacts that were produced as part of this build. And last but not least is the fact that as part of build integration, you can also use X-Ray. X-Ray is our software composition analysis solution. We did not cover it today, but just keep in mind that X-Ray could be part of the CI process, which means that X-Ray will scan your build or the outcome of your build and will let you know if there are any security issues or licensing issues with your build. Again, this is not the topic of the webinar, but it's important to know this. So with this, I think that we have finished our demo. Now, let's see what are the questions, and let's cover them. Okay. So I see there was a question about remote repository. Okay, so there's a question here about the remote repository and the fact that it created two repositories, a remote repository and a cache repository. So the thing about a remote repository is that it proxies another repository. Now, this repository, it could be a public registry, it could be a private repository, but it's a repository that we don't control, we don't manage, we can only access. And this means that this repository could become offline. So the cache, or the other repository that was created, which is the cache, is where all of the artifacts that we pulled from the remote location are actually saved for us to use later. Okay, and this is why we have two repositories that were created with the remote repository. Okay, and Tobias asked, you show the two approvals as metadata on the Docker build. Could you explain how this data is added to the build? So this could be done in several ways. One of them is using the REST API. There is an endpoint for build promotion. So for example, as part of your CI process, you can add a button that triggers this API, or as part of the, or if you want to use the command line interface, you can do that as well. But the idea is that there's an endpoint that you trigger, which promotes the artifact. Now, you can choose to add metadata on top of the artifact, but you can also choose to move the artifact between different repositories. Okay, let's see. Okay. How can we enforce that NPM dependencies are retrieved through Artifactory since the build is independent? So that's a great question. I want to show you something. I will reshare my screen. 1 second, please. So again, how do we enforce resolving dependencies through Artifactory? So if I go and search for the repository that we created, the virtual one, webinar NPM, and this is relevant for every type of repository, every type of package, there is a set me up button. Now the set me up button gives you the commands, again, depending on the context and depending on the package manager, it provides you with the commands that are needed to configure the client locally on your machine or on the CI server, it doesn't really matter. But with NPM, for example, we will configure the NPM package manager, the actual tool that is installed on our machine, to use Artifactory as the registry. And this window or this feature helps us do this and provide us with the credentials, for example. But it helps us set up our environment so that when we resolve dependencies through Artifactory, when we resolve dependencies of NPM, it will be done through Artifactory. Okay. Let's see more questions. Okay. So another question that I see here, if I have a repository system in place now, are there any tools that help with migrating to Artifactory? So yes, of course. It depends on which repository system you already have. For some of them, we have native tools that actually help you migrate from one tool to Artifactory. But also, you have the option of using the command line interface, for example, pushing and downloading artifacts. Okay. Let's continue and let's see if we have any more questions. Okay. Does it make sense to upload the complete test and code analysis reports along with the artifacts binary? So it does make sense to mark the maturity. So if, for example, to pass between the development phase and the QA phase, the artifact has to go through a series of tests, then yes, it does make sense to mark that. I'm not sure that you will need to actually upload the entire report, but you can also link the report within Artifactory. So for example, you could add a link as metadata on top of the binary for the test results. Okay, and let's see if we have any more questions. Okay. There is a question about naming. Okay. Can a virtual repository contain different technologies of different remote and local repositories? So a virtual repository is aggregating repositories of the same technology. Okay. And let's take one last question. Is Artifactory available on a cloud SaaS version and on a licensed on-premise version? So yes, Artifactory comes in two ways of deployment or management, either as a SaaS offering or as an on-premise version that you install by yourself, monitor, and control, or as a SaaS offering managed by us. Okay. If I use promotion function and it references a file by name, but if someone overwrites the file with the same name, would promotion fail? So keep in mind that the binaries or the artifacts are just data in the database. There's a link between the database or the database record and the file store itself. But when we are promoting, we're not promoting a file, we're promoting an artifact. And an artifact is represented by a record in the database, which also points to the file store. But it doesn't mean that when we move an artifact between different repositories, the file itself is actually moved. It's just how it is represented in the database. Okay, any use case of a virtual repository? So yes, of course. A virtual repository is super useful because it provides us with one URL to interact with. So again, if we're working with an NPM client, for example, when we write npm deploy, the deployment will push an artifact, will push a package to a local repository. But when we use npm install, for example, we will try to fetch dependencies, and those could be fetched from a remote repository. So with a virtual repository, we have just one URL and all the different repositories aggregated within it. Okay, I think it is time to wrap up. I don't see any more questions. So feel free to try out any of these features with a complementary instance, whether it's on-premise, that you install, with the assistance of our documentation, or as a cloud instance managed by JFrog. And of course, if you have any other questions or if you want a deeper technical discussion, book some time with our team. We would love to do that. And get started with the links that you see in the webinar console. They should appear now. And that's it. Thank you very much.
Great. Thank you so much, Roy, for this great presentation. We hope you found it useful. As we mentioned in the beginning, the webinar was recorded, and the recording with all the other resources and slides will be sent tomorrow via email. If you have any additional questions, please feel free to reach out to us at webinars@jfrog.com. Thank you once again, and we wish you a great day. Goodbye.